All right, so activity series rank the reactivity of metals and the solution, the ions. So we have metals on the left side and ions on the right side. Okay, so here's how interpret and how you use this activity series to predict one, if a redox reaction can occur, and two, who does who, what product you get. So you use this to do those okay. All right, if you look at just the metal on the left side, these are the metal. Okay, so at the top, highly reactive, and you guys know group 1, lithium, potassium, sodium, these are really reactive, and some of alkali earth metal, barium and calcium. Right at the bottom, these are non-reactive metals. So at the bottom we have gold really non-reactive, platinum, mercury, silver, copper. These are expensive metals. They're not reactive. Okay. All right, now start with group number 1. So the first group, the first group, which at the top, this guy are highly reactive, can react with even a small amount of proton in water. Okay, this element can react rapidly with aqueous hydrogen ion solution, which is an acid, or with liquid water to release hydrogen gas, because it's really reactive, can react even just regular water. Right? That's the reason why you never see lithium, sodium, calcium, potassium like in nature, because they can react even a moisture in the air. Okay. All right. Now go down to set number 2. So down here, moderate activity, you have magnesium, aluminum, manganese, zinc, chromium, and iron. Okay. So in metal 2 are less reactive than group 1. The first group, of course, they can react with the higher concentration of proton, such as dilute acid or warm water. Can react with water, but you have to heat it up, or you just use an acid. They can react with it. All right. Group number 3 down here. All right. This metal can react only with a concentrated solution of an acid. Okay, to release hydrogen gas. Water doesn't do any anymore. Heated up water doesn't do it because this has lower reactivity. And at the bottom, these guys are inert. Doesn't really do any reaction. Okay. All right. Now, when you think about it, so first of all, you need to know if you want to predict if a reaction will a redox reaction can occur or not. Metal and metal, like a solid metal, has no reaction. Put them together, there's no reaction, of course. Okay. When you want to make these two things react, one of them have to be a metal, the other one have to be in solution or be in a has charge in an ion. Okay, so metal, put them together. There won't be any reaction. They're not going to do anything. If you want a reaction to occur, you need one is metal, the other one is ion. Okay, so but may react, you have to check the reactivity. For example, right here. All right, let's say if you don't know if the zinc and copper can react or not. So let's say that if you have zinc and copper solution, all right, so copper 2, that's in compound now, not a metal copper. This is a metal copper. That is metal zinc. This is a zinc solution. This is copper solution. All right, the first reaction, so we have a metal zinc react with the copper 2 solution in blue, all right. Can this redox reaction occur? Okay, so what are you going to do? So you have to look at the reactivity, all right, of ions, and then of metal and metal and an ion. Okay, start with copper 2 plus. So start the one that will be an oxidizing agent. So copper 2 plus is right here. Okay, copper 2 plus can react with anyone, like with metal that are above it. Okay, that are above copper 2 plus. So zinc's right there, works. So that's reaction. Okay, now if you reverse a role, so we have a solid copper. Now we have a solid copper, which is a copper metal, dip into zinc solution. So the oxidizing agent in this case will be zinc. Okay, zinc. All right, now find zinc for me, zinc ion for me. Where's zinc ion? Zinc ion is there, right there. Okay, so zinc ion can react with anyone above, any metal above zinc ion. Is copper metal above zinc 2 plus? No, there's not copper there. Copper is down there, so there's no reaction. That's how you compare. All right, one more time. So let's just go with me. Get yourself familiar with how to use the activity series. Okay, now we're gonna take all this metal, dip it into an acid solution. An acid is a proton right here. That's an acid. Okay, right. An acid can react with anyone above it. Right. So start with magnesium. Where's magnesium? Magnesium is right here. No, not magnesium ion. There's ion and solution and solution. They don't do anything. So it gotta be one have to be solution. The other one have to be metal. Okay. So we have an acid solution. Magnesium metal is right there. Works. Now it can oxidize magnesium. So magnesium gonna go magnesium plus, and proton will become hydrogen gas. So it go reverse order like that. Okay. Now zinc is lower, also works, right? You can see there's a bubble right here. So magnesium, but magnesium is more vigorous, right? Reaction with zinc is it less vigorous because zinc is less reactive. If you go back right here, so if you have if you take the solution at the bottom, it's highly reactive ion. You know, at the top, on the left side, on the metal side, at the top, those are reactive metal. If you take reactive solution, react with reactive metal, the reaction will be very vigorous. Okay, but if the gap is closer, for example, reactive ion, but react with, let's say, relatively non-reactive, less reactive metal like cobalt, nickel, tin, the reaction can occur in theory, but it's slower. All right, and that's the reason why reaction with zinc compared to magnesium is not as vigorous, because zinc is less reactive than magnesium. Proton has the same reactivity, right? Now guess what? Proton and iron. So next one is iron. React with iron right here. Well, in theory it works, right? But the reaction is gonna be even less vigorous because iron is less reactive than magnesium and zinc, right? So you can't really see anything. So this iron is made of steel, except like in the middle. So outside it's coated with steel, and steel doesn't do any reaction, really inert, really strong. Okay, so you can see only in just okay, what's that? Or just the cut surface. Those are made of iron, and you see a little hydrogen gas there, even less reactive than zinc. Okay, less vigorous than zinc. Now, acid and lead. There's no lead in here. Is there any lead? No lead in here. Lead is actually right above an acid. In theory, of course, proton can, this acid can react with lead, oxidize lead become lead too. But when the reactivity really close, in reality, it just doesn't happen. It's just too slow. You can't really see it. Okay, but in theory, yes. If you leave it, like let's say a year, you start lead get like is corroding. Yeah, you will see it, because in theory, yes, it works, but it's just slow. Okay, all right. Now, water. Start with water. There's no water in here, but water is right here, so I just add water in here. So water can oxidize group 1. Of course it can. So it can oxidize all this group 1 and some of the group 2. Okay, and for magnesium and aluminum, in theory, yes, water can oxidize these two, but it's too slow. That's why for magnesium and aluminum, you have to heat up water to just spice it up, the reaction a little, to speed it up. Okay, not in boiled water. All right, so now based on the activity theory, which of these elements can reduce iron 2 to elemental iron? Well, iron 2 will go oxidize all of this. When iron 2 oxidize all this metal, it will become reduced. Right, so same thing here. So basically, this question asks you which of this metal can be oxidized by iron 2. Okay. All right. So we just look for iron 2 first. So it's an oxidizing agent. Iron 2. What's iron 2? Iron 2 is there. Okay. Calcium. Yep, works. Calcium at the top. Magnesium. Where's magnesium? Magnesium right here. Yes, works. Chromium right here. In theory, works. Okay, but I don't know how quickly this reaction will occur. Silver. Where's silver? Silver is inert gas. Inert metals is at the bottom. So no reaction for silver. Does it make sense? Okay. All right, let's practice the activity series together on the next video. Okay.